What's inside a black hole? We basically understand what happens outside the black hole as you approach its event horizon, that infamous point of no return. The event horizon is where the escape speed exceeds the speed of light. You'd have to be going faster than light, which is impossible for any bit of matter to escape the black hole's gravity. Inside the event horizon is where physics goes crazy. Calculations suggest that what the fabric of spacetime looks like inside a black hole depends on that particular black hole's history. It might be turbulent, twisted, or any other number of things. One thing's for sure, though, the tidal forces would kill you, see below. According to theory, within a black hole there's something called a singularity. A singularity is what all the matter in a black hole gets crushed into. Some people talk about it as a point of infinite density at the center of the black hole, but that's probably wrong. True, it's what classical physics tells us is there, but the singularity is also where classical physics breaks down, so we shouldn't trust what it says here. In a very specific mathematical case, the singularity in a spinning black hole becomes a ring, not a point. But that mathematical situation won't exist in reality. Others say that the singularity is actually a whole surface inside the event horizon. We just don't know. It could be that, in real black holes, singularities don't even exist. Wormholes are theoretically possible, given the right conditions. But those conditions almost certainly would never exist in the real universe. What would happen if you fell into a black hole? If it were a stellar mass black hole, you'd be dead before you passed the event horizon. That's because, if you think of a black hole as a pit, a stellar mass black hole has steeper sides than a supermassive black hole. The tidal forces become too strong too fast for you to survive to the event horizon, resulting in your spaghettification. Yes, that's the technical term. So let's travel into a supermassive black hole. Passing the event horizon, you wouldn't notice much, except some fun light effects and several extra Gs of gravity. But as you drew closer to the singularity, gravity should stretch and squeeze you as if you were dough in a bread machine. At this point you'd die. What would someone watching see as you fell in? As you approached the event horizon, a second person far, far away would watch your image slow down and redden. Theoretically, at the event horizon your image would freeze. But in practice you would disappear. The photons lose energy as it becomes harder for them to climb out of the black hole's gravitational well nearer the event horizon, and their wavelength would increase until it grew past the observer's detection capabilities, making the image invisible. So your image would redden and dim with time, until it faded entirely.